Alright, the last thing we want to go over is solving simple square roots in quadratic equations. So you're going to solve some basic equations that involve x squared and square root of x, which kind of will lead us into our next unit after the semester. Anyways, so let's see here. According to this, okay, so let's start off with the x squared, because those are kind of funky. Whenever you have an x squared, when x squared is isolated, I'm going to say that. Whenever you have an x squared, you need to say, take a square root to say solve. So those are opposites. So when I see like x squared equals say 16, see how first off the x squared has to be by itself. There has to be nothing on the same side of it. Take the square root. Square roots cancel out, like squares and square roots are opposites of each other. So the square and the square root will cancel each other out. So this and this are gone, leaving you just the x. And then the square root of 16 is 4. But you're going to put positive and negative 4 because positive 4 squared, 4 times 4 is 16. Negative 4 times negative 4 is also 16. So you will always, when you take square roots, put plus and minus for an answer. Okay, so do not forget plus and minus 4. Okay, so here's another example. X squared plus 4 is equal to 40. Now here, x squared is not by itself. So I need to get x squared by itself first. So I need to subtract the 4. And I would get 36. X squared equals 36. Then I can take the square root. And the square root of 36 is 6. But don't forget, put plus or minus. One more example of these. Okay, so I got x squared minus 7 equals negative 32. I add 7. Actually, I think there's 2 more examples of these. Okay, so I need to add 7 to get x squared by itself. I get negative 25. I'm going to take the square root. Now again, here's a negative. So if I take the square root of a negative, I put I. And square root of 25 is 5. And then again, notice I put plus and minus right at the beginning. So the first thing I did was plus and minus. So again, negative you put an I, 25 you put 5. Square root of 25. Okay, what happens if the square root doesn't come out even? Well, then you got to simplify it. So here, it's square root of 12, which we've seen plenty of times. The largest perfect square that divides into 12 is 4. 12 divided by 4 gives you 3. The square root of 4 is 2. So I'm going to put plus and minus 2 with a square root of 3. And there you go. So these really shouldn't be that difficult. It's just a matter of how well do you know how to simplify. Okay, now let's look at the square root of x. Well, again, the opposite of square root and squares are opposites of each other. So if you have a square root of x by itself, then you can square, and then that will be your answer. So 4 squared is 16. Notice how a squared and square root cancel each other out. X plus 5, first thing you got to do is get it, say the square root of x by itself. So I would subtract 5. I get square root of x is equal to 6. And then I would square that. Notice how I'm kind of writing these. 6 squared is 36. Last example. Okay, so here, what I would want you to make note of is that this time I put it under the whole thing. X minus 7 is under the square root. So all of that that's under the square root, it's by itself. In other words, the square root symbol is kind of by itself. So I can square this to get rid of the square root symbol, but I'm also going to square the 3 at the same time. Notice that all you do when you square is get rid of the square root symbol. It's gone. The radical is gone. 3 squared is 9, and now I can solve for x. 9 plus 7 is 16, and so x is equal to 16. And again, if you wanted to check your work, you could easily do that. I mean, if you put 16 in here and say 16 minus 7, you would get 9, and the square root of 9 is 3. So, I mean, it works out. So, there's a quick, easy introduction to that. It's really not that difficult, I don't think. I mean, at least that's my personal belief. So there you go. Anyways, if you have any questions, feel free to ask, but there you go. That's it for today. Thank you so much.